Okay, so hello guys, welcome to the world of software testing, and this time let's talk about boundary value analysis. So, in the previous video we have learned about equivalence partitioning, and now we will extend it. Yes, boundary value analysis is an extension of equivalence partitioning. And how does it work? Let's see a straightforward example. And this time, let's test the font size box in Apple Pages application. Those of you who are not familiar with Apple Pages, this is just the Microsoft Word in Apple ecosystem. Let's assume that we need to test this size box. Actually, if you do some exploratory testing, so you just inserting some values, then you will see that the allowed values are from 1 to 1000 inclusive. So if you insert an average value, the font size will be bigger or lower depending the value itself. So let's recap equivalence partitioning. What do you think? What kind of partitions should we define or should we test in this case? Of course, we need to test a valid partition, so between 1 and 1000, and we need to test invalid ones below the 1, and of course some values which are higher than the 1000. Actually, it's one invalid partition, and you can divide more sub-partitions. Here is somewhere the figure. Okay, and because of this is a text box, then you can insert anything. So we need to test at least once then what happens if we insert some non-whole integer number, okay, 1.2, or what happens if I insert a character or something. Okay, so we have equivalence partitions, but let's extend it. We have some boundaries, so from 1 and 1000. I said that these values are allowed ones, so the specification says that 1 is a valid value and 1000 is a valid value. But not every time this sentence is true, so sometimes the specification is vague and we don't know anything about these each values. And we need to test it. And I must say that also developers and programmers usually make mistakes around boundaries. So how should we test it? Our first thought that, okay, let's test these boundaries, the 1 and 1000. Actually, it's okay, but if you want to know how these boundaries really behaves and the partitions, the neighbor partitions, how does behave, then we need to test the neighbor values too. So in the first case, let's test the 0, the 1 and the 2. And in case of 1000, let's test the 999, the 1000 and 1001. Please note that with this technique, so if we test 3 values per boundary, we test the left and right partitions too. So in an ordered partition, with this technique, we test the equivalence partitions and the boundaries too. If there is any behavior which is not normal, then we will notice that. And if the specification is vague, then we need to ask the author of the specification. Okay, but wait a sec. Now we have test values which tests the partitions and the boundaries too. And there is some space for optimization. Let's assume that we need to cover all partitions and the boundaries too. In the first case, if you see, in case of 1 and 2, these two values behaves the same way. And this is the same story at 999 and 1000. And because of these 4 values does the same, then probably we could optimize it. And what happens if we test with only these 4 values? So the 0, 1 and 1000 and 1001. In this case, we cover all partitions, and also if there is any mistake, then we have a chance to notice any bugs in case of the boundary handling. This is when we test with 2 boundary values per boundary. earlier what I showed to you, where that technique uses 3 boundary values per boundaries. Actually, the common answer is that if the testing is cheap for you, so you have a fast feedback, then you can test 3 boundary values and you will see everything. If the testing is not cheap for you, so for example, you need to wait for the test environment and you need to optimize it, then choose 2 boundary values per boundary. Okay, this is simple, but let's add some extra boundaries. These are some extreme values. Every time if you test boundaries, try to add the minimum possible value what you can insert and also add the maximum possible value and the 0. Because these 3 values are strange enough to test. So the 0 usually behaves differently in case of calculations, especially the multiplication, and the extreme values can cause some not only functional but also some performance bugs or issues. For example, the application handled it, but in a very slow way. So finally, in this functionality or in case of this font size box, these boundaries are most efficient with 3 values, and this is the version if you test 2 values. Then please note the extreme boundaries and the 0 is always an interesting values, so you can test it. Okay, I hope you enjoyed this video again. If you are new here, please consider the subscribing, and if you have any question or recommend some topics, what kind of video would you like to see, just leave some comments or write me directly into one of my contacts. So thanks for watching.